Hey friends, these are the last two identities that I really want you guys to leave the class knowing. There are lots of others that we did not cover. They're listed on this sheet. If I have time, I'll link to them and link videos about them. But these two I want you guys to be familiar with. They're called double angle. The first one says that the sine of twice an angle equals 2 times the sine of that angle times the cosine of that angle. And well, you can read these. The other one says cosine of 2 theta equals cosine squared minus sine squared. But of course we have all these other ways to rewrite both cosine squared and sine squared. So, for example, if I replace cosine squared with 1 minus sine squared, I can turn this expression into this one. So that's another way to say cosine of 2 theta. And then if I replace sine squared with 1 minus cosine squared, I can write this like this. So cosine 2 theta has multiple ways to represent it. And the sine of 2 theta is interesting because it has a sine and a cosine multiplied together. There's a few things kids tend to do incorrectly when they see this for the first time that I want to try to explain, and then you'll see how to apply these to solve some equations. Let's talk about this is the one that really pops up a lot next year. And what I want to point out is sometimes kids make the mistake of thinking that I've kind of factored a 2 out. That's not what's happening here. So sometimes people see this expression and then they mistakenly think that if they have, say, sine of, like, say, 3 theta, they can rewrite that as 3 sine theta cosine theta. That is not what's happening. What's happening is whatever this angle is, this angle will be twice whatever that angle is, and this 2 in front is always a 2 in front. Okay, so I know that doesn't make a ton of sense, so let me show you what I mean. If, for example, I had the sine of 6 theta, and I wanted to rewrite it, what I'd want to first do is figure out what angle did I double to get 6 theta. You know, like what do I multiply by 2 to get 6 theta? So in a way, what I have here is sine of 2 times 3 theta. Now to apply the double angle formula to this example, what I'd say then is the 2 definitely comes out, and then I have a sine of 3 theta cosine of 3 theta. Now I'm going to explain this carefully. We're going to do a slightly different example so you get the idea. But what happens is, so sine of 6 theta equals, it's always a 2 in front, and then it's sine of whatever this is, take half of that. That's how this identity works. This angle needs to always be twice as big as whatever angle's over here, and there needs to be always a 2 up in front. We're not pulling a 2 out, like this 2 and this 2 don't mean the exact same thing. Let me clear my screen and show you this one more time. Let's say I had a sine of 24 theta and I wanted to break it up using the double angle identity. The double angle identity always has a 2 in front, and then it's sine of and cosine of whatever half of this is, 12 theta and 12 theta. So it should always be the case that whatever this angle is, this is twice whatever that angle was. So if these are both 12 theta, this will be 24 theta. And it's always a 2 out in front. For the cosine of 2 theta, I want to point out how much this looks like an identity that we already know. This looks an awful lot like cosine squared plus sine squared, which we know equals 1. So I just want to put that on your radar so that when you guys see cosine squared minus sine squared, you don't think about this one we've been using all the time, but I do want you to recognize that as being cosine 2 theta. Now let's see how to actually use these in problems. And if I have time, I'll make another video explaining where these come from. But for now, I just want you to see how to use them. The next 2 videos, we'll do the first 3, maybe 4 problems of your homework. We'll just do them together, and then you guys can do the remaining problems on your own.